Hi, welcome. This is the last videos I'm going to talk about for grade 5 math. My name is Julie Roy, and I'm a grade 5 teacher right now. And the focus of the current videos are multiplication and how students can build on their basic multiplication facts to be able to multiply larger numbers. We've had previous videos where we talked about multiplying a 2-digit by 1 digit, a 3-digit by 1 digit, and those things need to happen before you start looking at multiplying a 2-digit number by a 2-digit number, which will be the topic of this particular video. So now, when we want to multiply a 2-digit number by a 2-digit number, the same mental model that we've been using throughout our multiplication facts and larger number strategies remains the same, and that's the goal of having strategies for students or mental models. You want mental models that last forever, not just for a particular grade level, but throughout their schooling careers. So when you multiply a 2-digit number by a 2-digit number, it can be any 2-digit number. So we'll start with 26 times 38. The idea is to look at it and think, what does it mean when I multiply two things together? What model could I use? Well, when I multiply, I'm really looking at the areas of different rectangles. Okay, so I got kids to build them when they were smaller numbers and manageable, but at this particular point, drawing 26 things times 38 thing is not reasonable. You want students to use what they know, what they've noticed number patterns, and extending these patterns with just a model. Okay, so the first thing I want to think about is the smallest side. Here I drew something that looks more like a square, but that's not so important. 26. Well, how could you break down 26 to make that more manageable to multiply? Because multiplying anything by 26 is very difficult. So you would want to break down your 26 in terms of 20 and 6. So your length that measures 26, you've broken it down into two parts, 20 and the 6. Now you want to look at your other length, the other dimension of your rectangle. That measures 38. How can you break down 38 in ways that would make sense? You use the same logic and break it down into 30 and 8. Okay? So before you draw your rectangles and you make your partitions, you need to know really what are you looking at, because different multiplication will have different representation of these rectangles. And you don't want to pre-do a model. You want to think about it as you go so you can reason about the actual problem at hand. So here, 26 times 38. The thing that you will notice that students need to be able to do before tackling a problem like this is multiply two multiples of 10 together. And then that seems more difficult than it actually is. So looking at 30 times 20, how do we get kids to reason out what that is? And I could use number patterning for this. So 30 times 20. What can you think about? What do you know that looks similar to that? Well, you already know what 30 times 2 is, and you said that was 60. So 30 times 20 needs to be larger than that, okay? So you can think of your 30 as your 3 tens, your 20 as 2 tens, and now you're multiplying 3 tens times 2 tens. You know the answer is going to be 6 something, but what is the exact something it's going to be? You can go back to thinking of 10 times 10. What is that? 10 times 10 is always 100, okay? So what you're starting to look at is that your 3 tens times your 2 tens is going to be 600. Okay? Two ways to look at it. You can look at it with the place value and dig deep through that, or just look at your number patterns. Well, 30 times 2 is 60. 30 times 20 has to be greater than that. How many times? It's 10 times greater, because 20 is 10 times greater than 2, and 10 times greater than 60 is 600. Okay? Very important, again, to not look at the numbers of 0 that you're tackling down, but more so reason it out. What does it need to be? What can't it be? What do I know it can't be, because I already know what this is. This can't be 60. Okay, so it needs to be 600. So 30 times 20 is your 600 box. 30 times 6, well, you already know that 3 tens times 6 is 18 tens. That's 180. 8 times 20, well, 8 times 2 10 is 16 tens. And that is 160, and 8 times 6 is your 48. So now you're led to add these things together. So you have your 600, you have 700, 800, then you can notice that you have 60 and 40. That's your 900 right there, and you have 88 left. So you will have 988 as your final answer. So you see how when you add these things, you don't want to write all the numbers you're adding, but mostly just take numbers one at a time and put them together in their natural groupings. Try to hold that information in your head. Okay, most students will need to add 2 together, then add the third one to the 2 they've already added, and add the fourth one to that. And that's a good strategy when you're adding 4 different numbers. Students that are not strong adders will really struggle with this, and this is not really the problem that they're ready to tackle. You'll need to go back and practice their addition skills before they're able to multiply efficiently. Okay? So this would be how you would do a 2-digit by 2-digit. I'll give you a second example just to show the importance of multiplying 2 multiples of 10 again together. So we'll look at numbers that give greater results and see the same logical thinking applies. So if I had a number like 83 times 47, okay? Well, 83 times 47 is the same idea. I have this one big rectangle where my largest side is 83, my smaller side is 47. I'll break down my 83 in terms of 80 plus 3, and I'll break down my 47 as 40 plus 7. Okay? So again, I see that this problem has 4 parts that we'll need to add together. I've just divided my big area into 4 smaller manageable pieces to make the big multiplication easier in my head. Okay? So 40 times 80, again I have 4 tens times 8 tens. Well, that's 32 hundredths, right? Again, if we know that 4 tens times 8 is 320 because we have 32 tens, 4 tens times 8 tens cannot be the same answer as 4 tens times 8. It has to be 10 times larger. Look at tens times tens makes hundreds, so 3200. That's how you would derive that answer. 40 times 3, you have 12 tens. 80 times 7, well, 8 times 7 is 56 tens, 560. And 7 times 3 is your 21. So here again, your 4 parts. So 3,200 plus 500, that's 3,700, 800, right? And you get your 60, your 20, your 20, which make another 100. So you have 3,901. Okay? So this concludes really how you would multiply 2-digit by 2-digit together. Again, if students need to write some of these smaller additions down, you can let them do that. This is not a mental problem because there are 4 parts to it. Most human beings cannot process 4 parts in their heads. That just takes too long. Their working memory is limited. So thank you again. This concludes our multiplication series. Hope you enjoyed.